Space and Rocket Review. You two girls, tell your friends. Space and Rocket Review. You in the hat. You two girls, tell your friends. Space and Rocket Review. What's going on, everybody? Everybody doing okay? Doing good? Yeah? Maybe? No, yes? Banana? Banana, perhaps? Yes. Banana. I agree. I'm just compiling a couple of more pictures here. Give me one sec. Just putting together a couple more pictures. And all right, I think we are good. Welcome to the Space and Rocket Review. Did you already make some progress in cleaning your garage? Yeah, yes I did. The L69 launch being a little bit earlier today kind of just threw a monkey wrench in my plans, but I said we'd cover all rocket launches, so that's what we're doing. So I guess that's where we start space news. I hope everybody had a good weekend. I will, if you missed it, I will show you the final result of the L69 mission. So a Falcon 9 launched out of Cape Canaveral Space Force Station, pad 40, this basically early afternoon. Hang on one second. Oh, okay, cool. I noticed something, but anyway. The NRL 69 mission did make it into space. We got a report of mission success from the National Reconnaissance Office. And the booster, 1092, completed its, I got to look it up, second flight today. Here's some footage of the landing. Take a look at this.
Landing was deployed.
Oh, little baby, just second flight.
Shut down.
So that was booster 1092. Second flight, 26-day turnaround. The NROL mission, the National Reconnaissance Office L69 mission was the 34th mission for SpaceX of 2025. Pretty cool. Pretty good launch, pretty good landing. Everything looked routine. We got in report, they reported a success from the National Reconnaissance Office, which is great. Was that the one they used 9 days ago? No, Alucard. That booster is 1088, I believe. Yeah, that's 1088. 1088 flew Spherex Punch, and then it flew the. It was a National Reconnaissance Office mission, and I'm blanking on the name, and, don't like that I'm blanking on the name. It was the L57 mission. That booster was on a 9-day turnaround. Wrong coast for that. Yeah, wrong coast. The 1092 is an East Coast booster. I say East Coast booster because SpaceX tends to leave Falcon 9s at their places, at their launch sites. So they're usually, sometimes there's West Coast boosters. I mean, sometimes they move it back and forth, but I've noticed generally lately, like, they have East Coast operations and West Coast operations, which is pretty cool. That camera angle. Okay. Fuel is not stored in the balls. All right. Anyway, so, yeah, L69 was a good mission. We got a report of success from the, hold on, National Recon. Hang on. I saw it pop up. I got to get the link. It's buried in the link of links. There we go. There we go. There it is. Mission success for NRO and the Space Force Space Systems Command. There we go. Mission success. I don't know if the National Reconnaissance Office is playing some voxel-generated game here, but yeah, We don't really know what that satellite was. I'd assume it might have something to do with folding. Maybe. This very interesting thing about that launch. What the heck? Very interesting thing about the L-69 launch. If we go back and take a look, you know, here we'll just go to the SpaceX cast. So this Falcon 9 had a extended duration upper stage on it. So that's important. It's important to look at this. All right. So see that gray stripe right there? That gray stripe is a thermal protection system for the RP-1, for the propellant, for your rocket grade kerosene on the second stage. It's an insulator to make sure that the propellant stays at the right temperature. SpaceX does this when their second stage needs to do a long duration mission. So something that usually indicates going to some type of high orbit. This satellite launched into a 55-degree inclined orbit. Basically, it launched up the coast, like it was kind of going to the space station. But don't get me wrong, it was just a similar inclination. This is not going anywhere near the space station, especially with that long duration stage. Now, what does the long duration stage do? Well, like I said, it insulates your propellants to basically make the propellants last longer. Yeah, that's the big one. They shot a hummingbird into space. Yeah. So that one, yeah, it was a long duration stage indicating a high orbit, but that's about all we know. Anyway. Hi everyone. Anyone in this community that can help me? I don't want to interrupt the stream. I'm currently learning nozzle theory with isentropic flow. What I currently don't get as a basic, if the nozzle walls are passive and follows natural expanding flow, or if the nozzle walls are actually guiding the flow actively. Oh. I can get you that definition. Hold on. Give me 1 second. Let me get my my little book of tricks. Give me 1 second. And don't worry about interrupting the stream. This is the kind of stuff I love. I love this stuff. I love figuring this stuff out. This is my favorite.
Discovery, go and throttle.
Probably going to get put on a list somewhere one of these days, but, you know, whatever. It's fine. Okay. Big boy. Thanks for that prime sub, dude. All right, so let's check this out. So, hey, Space Pope, what's up? How you doing? That's my dinner plate. Put that back over there. All right, so isentropic flow. Okay, if the nozzle walls are passive and follows natural expanding flow, if the nozzle walls are guiding the flow actively. Okay, so see if I had to guess, and I'll get the definition for you, the nozzle walls are there for a reason, okay? They're there for a reason, especially on an upper stage. They're guiding the flow. They're not, if I'm understanding what I think I'm understanding, I'm pretty sure they're there for a reason. A good way to think about stuff with rocket science is that it's not there for no reason. Everything is there deliberately. Everything is there on purpose. So, see, well, if you don't have this book right here, Modern Engineering for Design of Liquid Propellant Rocket Engines by Dieter Heusel and David Huang. This is the book. You want to learn about propulsion? This is the book to do it. Either that or Rocket Propulsive Elements by Sutton. Those are the big ones. So let's look for isentropic flow in the index. Does anybody here still know how to use that? Don't know. L-69 might be a satellite data system quasar launch. Oh, so it's launching a microwave. I had a quasar microwave back in the day, which are military communication satellites. I mean, National Reconnaissance Office. I mean, Space Systems Command. Math checks out, homie. They are usually launched into lightning orbits. Yeah. I'm studying rocket propulsion elements. You're starting RPE at the elements. RPE at the moment. Gotcha. All right, isentropic flow. Mission detection. Yeah, I have Sutton on my shelf. Yeah, RP. I have RP 8th edition. It's down in the house. I don't know why it's down in the house. It should be up here, but Exosphere. Friend saw probably the second stage from L69 venting from Sweden. Yeah, it's maneuvering. Actually, Exosphere. It's maneuvering around on its way out to whatever orbit it's trying to get to. We don't know. How could you gimbal without the nozzle causing a change in direction? What do you mean, Wendy? The origami crane is the Crew 10 symbol. Oh. Trey 9, you emailed Senator about the Isaacman hearing. They responded and said they would go ask and get me a net date. Also, they said they want him confirmed too. Killer. Hey, nice, dude. Very good. Yeah, people saw it in the UK. That's the second stage maneuvering around. What you're seeing is the plume being backlit because it was towards sunset, well, after sunset for you guys. You're seeing the plume backlit by the sun. So in this case, it's the plume from Falcon 9 second stage's cold gas thrusters. Not a lot of people know that Falcon 9 second stage has the same thing the first stage has on it for maneuvering around in space. Fun fact. It looked like a spiral. If the stage is rolling, of course it's going to look like a spiral. Why would you roll the stage? Thermals. You barbecue roll the stage so one side of it doesn't get too hot. That's why it looks like that spiral there. Isentropic. I don't see anything about isentropic flow in here in the index. Tivola, do you think there's something that would be... Let me see. So, okay, nozzle theory. All right, let's try that one. Hydrocoptic nozzle veins. I'm pretty sure the nozzle is there to guide the flow. I'm pretty damn sure. But, yeah, nice, Max. That's funny. Flanges, nice. HIJKLMN, nozzles. Area ratio, boundary layer, clustered, contraction area, convergent, divergent, exit velocity, expansion area ratio, expansion deflection, flow Mach number, flow process, isentropic pressure ratio. Got it. I got it. Page 10? Really? Wow, that's right at the beginning, huh? Did you just start, Ciavola, or what? That's way up at the front. So is that the actual push or thrust? They're little tiny thrusters that are on the back of the stage. Okay, here we go. Let's take a look. I should probably get a camera so you guys can see this, but I'm gonna read to you. Give me 1 second. I just got to figure out where to start. Okay, gas flow through nozzles. Let's go. The prime function of a rocket nozzle is to convert efficiently the enthalpy of the combustion gases into kinetic energy and thus create high exhaust velocity of the gas. Plain English way of saying that, it farts out a lot of gas really, really quickly. The nozzle is the most efficient device for accelerating gases to supersonic velocities. The nozzle makes the gases move faster. Believe me, I'll translate turbo encabulation to you guys. Rocket nozzles are conventionally converging, diverging de Laval type, so basically it looks like an hourglass. With a cross-sectional area decreasing to a minimum at the throat, the skinny part of the hourglass, and then increasing to an exit area. The flow velocity through a nozzle increases to sonic velocity at the throat and then increases further supersonically in the diverging section. Bingo. Yep. That's how you get a rocket engine to work. It has to go supersonic in the throat. If it doesn't go supersonic in the throat, you made a really nice flamethrower. That's basically filling up. If you think of fire like a quantitative thing, and Ciavola, this is for everybody else, just bring everybody up to speed. If you think of fire in a rocket engine, like, you know, you blow up a balloon, right? The balloon's going to shoot that gas out the nozzle. Like, you blow up a balloon, you let it go. That is essentially what a rocket does, only it's better if you heat the gas first with a fire. Right? So think about like fire as a quantitative thing. Like all a rocket engine does is make fire. It makes a lot of fire. And what it does with that fire is pressurize it inside of a combustion chamber, just like you'd pressurize water in a pipe. Same idea, only you're doing it with gases. That's hard to do with gases, right? Because gases are compressible, right? With water, you just squeeze it and it goes out, right? So you got to fill the combustion chamber up with fire to the point where gas wants to shoot out the bottom at very, very high speed. It has to go supersonic. If it doesn't go supersonic, you're not filling your combustion chamber up enough. And once again, you just made a very nice flamethrower instead of a rocket engine. Okay, here we go. Yeah, if you heat up the gas will expand and you can pressurize better and it'll move faster. Goddard figured that out. Well, actually, the Chinese figured that out 5,000 freaking years ago. Goddard figured out how to do that with liquids, which is big deal. All right, let's see. In practice, for one-dimensional isentropic expansion, ODE calculations, it is assumed that the gas flow through the nozzle will be an isentropic expansion, and that both the total temperature and total pressure will remain constant throughout the nozzle. Yep, that's really, really important. Maintaining uniform pressure. You get cavitation in the nozzle, it explodes. That's usually the net result for anything that doesn't work. Exactly how you want it with a rocket engine, it's usually an explosion. Just in case anybody was wondering. Okay. The pressure ratio PT divided by PC sub NS between the throat and the chamber is called critical pressure ratio and is solely a function of the specific heat ratio. Basically, pressure is derived from how much heat you could put into a gas. Yeah. Because ideal gas law and whatnot. I mean, it's a little more complicated than that. It's represented by this equation. PT divided by PC sub NS equals 2 divided by, it's fancy cursive y, which I forget what that is. Y plus 1 to the exponent y divided by y minus 1. Any questions? Cool. Good. No, put your hand down. I don't care if you have questions. The static pressure PT at a nozzle throat with sonic flow, where the maximum flow per unit area occurs, is defined as critical pressure. The velocity of sound is equal to the velocity of propagation of a pressure wave within a medium. It is therefore impossible for a pressure disturbance downstream of the nozzle throat to influence the flow at the throat or upstream of the throat, provided that the disturbance will not create a higher throat pressure than the critical pressure. Rockets flow in one direction. That's why I always say, if an explosion comes out the side, you got a big problem. And that's why I describe plumbing with rocket engines as upstream and downstream. Rivers don't flow backwards, unless it's a tide pool. But rocket engines are in fact not tide pools. Fun fact. It is one of the characteristic features of an attached, diverging, or de Laval nozzle. However, that sonic velocity in the nozzle throat is maintained even if the back pressure, ambient pressure at the nozzle exit is greater than the pressure required at the throat for sonic velocity. As a result, a pressure adjustment recovery must take place between the throat and the nozzle exit, which is at ambient pressure. This adjustment may take place through subsonic deceleration, isentropic, or by way of non-isentropic discontinuities called shock waves, or a combination of both. Figure 1-11A presents several of the possible conditions that may occur in an overexpanded nozzle. Yeah, this is what I thought, Ciavola. Yep. Okay, so the short answer to this is yes. The nozzle walls are there to prevent isentropic flow from happening. You don't want that. So what happens when you get this type of thing? If I'm understanding this right, I didn't know the name for it because I'm me and I'm not a rocket scientist, but long story short, remember I told you that fire needs to fill up the combustion chamber and then it needs to accelerate to supersonic speeds in the throat and then accelerate further because it's expanding as it goes down the nozzle? if you do not make enough boom to fill up that nozzle, you're going to get you're going to get what's called overexpansion, meaning your nozzle is too big for the fire coming out the back. This is why second stage nozzles have different expansion ratios than first stage nozzles. First stage nozzles are kind of little stubby boys. Second stage nozzles have these gigantic expansion ratios. They're huge, right? Part of that is because of ambient pressure. You have to take that into account, right? But the big one is, if you put a second stage nozzle on a first stage engine and then fired it, the explosion that the engine makes is not going to be enough to fill up, like physically fill up the nozzle. And the pressure, your ambient pressure, is going to creep up in the nozzle and you get flow separation inside. All right. This is why rocket engines generally run with what's called I always get it backwards. They run with what's called an underexpanded plume. Basically, the fire that's coming out of this rocket engine, the gases that are coming out at super high speeds, are enough to fill up the nozzle and then some on first stage nozzles, which is why first stage nozzles tend to be these little small boys. They're little small nozzles, right? Page 9, okay. So, here, I'll show you a Raptor engine this is actually an interesting example here, but here, I'll show you. Come on, make the fire. Okay, so, oh, that was a little wimpy firing. I don't want that. Do this one. Oh. Okay. All right, Shivola, you see this thing right here? You see how the gases, like, okay, if you follow, like, the contour, so that what's called the expansion ratio, the shape. The expansion ratio is a nice way of saying the shape of the nozzle, right? It's a ratio of, rise over run, basically. How long is it versus how wide is it, right? You see this right here? If you follow that contour, right? Note that the gases right here go out at the rim of the nozzle. That's a slight underexpanded nozzle. Basically, once again, the explosion is enough to fill that sucker and then some. You really want to make sure this is a thing with first stage engines, or else the atmosphere, your ambient pressure, like the book says, will creep up in here and something will explode. Something will explode. So, let me just try to put it into a better definition for you, just in case. I love doing stuff like this. This is my favorite thing to figure out. Yep. Okay, it is one of the characteristic features of an attached diverging or de Laval. I read this part already, but we'll recap it. Or de Laval nozzle. However, the sonic velocity in the nozzle throat is maintained even if the back pressure, ambient pressure at the nozzle exit, is greater than the pressure required at the throat for sonic velocity. As a result, pressure adjustment must take place between the throat and the nozzle exit, which is ambient pressure. This adjustment may take place through subsonic deceleration, isentropic, or by way of non-isentropic discontinuates called shock waves. So, you see this right there? See this thing right there? The plain English way of saying that is that if this thing is happening right here, you got a big problem. Your engine's going to explode. In short, pressure lower than ambient might be present in a supersonic nozzle. The higher ambient pressure cannot advance upstream within the nozzle. Yeah, higher ambient pressure cannot advance upstream in the nozzle since gases are flowing with supersonic velocity. An exception to this is in the region of the flow along the nozzle walls, where, due to friction, a boundary layer of slow-moving gases may exist. Here you go. Here's really what we're getting. This is the meat and potatoes. In the subsonic boundary layer, ambient pressure may advance for a distance, forcing the low pressure center jet away from the walls. That's what I was talking about. That's usually bad. But a lot of rocket engines use that kind of medium between the nozzle wall and your boom boom gases to film cool things. Good day, sir. What book is this? Modern Engineering for Design of Liquid Propellant Rocket Engines. Okay. It might be expected that the point of separation will be at the point of optimum expansion, but separation usually occurs further downstream. In fact, it rarely occurs at all in conventional rocket nozzles with the design region of operation, unless an extreme case of overexpansion exists. Yeah, the opposite of underexpansion is overexpansion, meaning your nozzle is too big. You're allowing ambient pressure to get back up there, and then isentropic flow happens inside of the rocket engine, which is bad. That's bad. You said that crossing the streams was bad. Yep. Okay, good. Safety tip, Egon. All right, cool. Thus, in many cases, it is correct to base all nozzle calculations on the assumption that no separation occurs. I mean, you don't want flow separation in the nozzle, so that'd be good to take that into account in your math. Some useful relations for ideal gas flow through a nozzle take the following form. Oh gosh, exit velocity in theory and math. Oh boy. Oh boy. So they test Raptors on the ground with vacuum nozzles. Does that mean they found a happy medium, like they gave up some performance? No. Elements for gas turbine propulsion is your go-to for reference. Good call. I have a question. Will this be on the test? Oh, yeah. Hi, AJ. What do you think is the most promising new European launch company? I like Rocket Factory Augsburg, Original Min, but ESAR is really winning me over pretty fast. You know why? They have a rocket, and the rocket hasn't exploded. There was a cool Hydrolox combination first upper stage engine design, the XLR-129, that had a deployable nozzle expansion for weird CIA spaceplane concepts. I think the XLR-129 was used in the X-15. I believe you have shown this feature on slow-mo from testing at Massey's. Yep. Don't first stage rockets have flow separation on sea level to get optimum at Qmax? You quote unquote no, they do not. They make the nozzle too small. Civil, so going back to your question, the nozzle is there. They shorten the nozzle. The nozzle is short. You have a smaller expansion ratio than on an upper stage engine. They keep it small on purpose. Now, okay, the reason why, and this is where this book is going to go, I guarantee you it's in the next chapter. But I can explain this. I don't need the book for this. I just needed a refresher on isentropic flow and what the hell it is. It's basically flow separation. It's the same idea. If I'm understanding that right. Nerds, correct me if I'm wrong. I think I got a grasp on this concept. So here's the thing. Look at this flame. Okay? Look at this flame! You see see what's going on here? It's hourglassing. See that? It's going in and out and in and out and in and out. Why? So at the rim of the nozzle, right? You're getting the gas is going up. That's once again, that's their under expansion. The nozzle is smaller than optimum.
Oh, this is space. I'm in space.
The optimum expansion ratio would be out here somewhere. But you don't want to do that because if you do that, you're running the risk of having isentropic flow inside of your rocket engine or just flow separation. That's the plain English way of saying it. Basically, the gases from the ambient atmosphere are trying to creep up inside of the nozzle because your explosion isn't filling it up. So they cut the nozzle a little bit before optimum, right? The atmosphere does the rest of it for you. So what do I mean by does the rest of it for you, right? You're not like peak expansion ratio efficiency right here. But it's close enough to make sure that the rocket engine doesn't blow up. So they cut it a little bit. You're close to if like 100% efficiency right there. Like with basically 100% efficiency would be accelerating this gas as fast as you possibly can with what you have, right? That has to do with exhaust velocity, right? You know, if you just had this thing cut, if the thing was completely cut off, you'd make a little tiny jet that goes like this. But since you can accelerate the gases with your de Laval converging diverging nozzle, right? You make them go faster. But there's a theoretical maximum speed that they can come out at. Right here is where they're at max, like that's the best you're going to get. But the nozzle's cut before that because the atmosphere will take care of it for you. right? You also got to take into account that where the rocket engine goes, you can't necessarily rely on ambient pressure, right? So just because the rocket engine works fine at sea level doesn't mean it's going to work fine, a first stage engine, right? Just because it works down here at zero sea level, right? Doesn't mean it's going to work exactly the same at 10,000, right? Your gases are not going to flow the same because your ambient pressure is different. So, believe it or not, because the atmosphere doesn't, the plain English way of saying this is the atmosphere gets in the way down here and it forces your gas to be in kind of an hourglass, right? Forces it to be in an hourglass like this. Once you get higher up, the gas goes from kind of a cylindric shape to more of a cone shape coming out, right? And then you need the nozzle to guide the gas in the right direction because the atmosphere is not going to do it for you. Why is the atmosphere not going to do it for you? Because there is none. I got you, brother. I was waiting for you in the wings, dude. Explore Uranus with the resub there. Thank you. Yeah, Forge. Yeah, pop in. So, all right. Now, I know a couple of different questions that people are asking. First and foremost, Sivola, is this helping? I can explain the basics. It's when you get into the more advanced stuff where I'm like, potato, 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 you know, like. So, two things. You need a bigger nozzle up there. That's very important because you have no atmosphere to guide the gases for you. Down here, you need to find the medium between a short nozzle, right, and like 100%. What's the right word? Hold on. I always get the words wrong. I understand the concept, but my brain goes, potato. You have to get the right expansion ratio to be like just before like 100% of. Frick you, Windows! I put the Windows sounds off. You suck. Anyway, you have to get the nozzle cut like right before 100% efficiency, right? Like basically accelerating those gases as fast as they can, or else you're gonna get that flow going into the nozzle. That's bad. Now, the second part of this question, okay? And this is, dude, propulsion is my thing. Like, I love it, but the problem is that it's rocket science, and my potato brain doesn't understand it very well. Now, a lot of people ask about vacuum Raptor, okay? So, Bob, you asked about vacuum Raptor. So, how does SpaceX do that? How do they fire an upper stage engine down here? Well, long story short, when you're making 300 bar chamber pressure, it doesn't matter. When you're making 300 bar chamber pressure, all right, you can fill up any nozzle you want. That's part of the reason why Raptor is so damn good. Doesn't matter if it's at sea level. Any other upper stage engine, like a Merlin vacuum, you tried to fire it down here with the rocket nozzle on, it'll explode. It will explode. Yeah, remember from the book, upstream pressure takes precedent. That's really important to understand. Why not use an aerospike for this issue? What's the downside of an aerospike? You have a little bit more complex plumbing with an aerospike, Graham. But if you're opting, I mean, it really comes down to vehicle design. If you're opting for a two-stage rocket, aerospikes make no sense. You're intentionally complicating your nozzle design for not that much more of a gain. So in the application of an SSTO, an aerospike would make a lot of sense. They tried that once, and then we decided we didn't want to do that. Such stupid clown. Aren't aerospikes also really hard to scale? Not necessarily, Kate. If anything, de Laval nozzles are, convergent divergent nozzles are harder to scale. It's harder to make an explosion to fill up a bigger engine. SpaceX seems to have figured out that problem, though. Your mic are over modulation. Okay. I turned it down just for you, buddy. Yeah. See, well, the other thing is, you know, if you have a nozzle like this, you can't put anything in the center you can't put anything in the center here for bracing, right? So this is actually something cool. A little bit of a fun fact. So Vacuum Raptor does this, and space shuttle engines do this as well. Okay, so if you notice, there's a brace. See the brace? They have a brace right there. So SpaceX has a stiffener ring around the exterior of the nozzle, right? To prevent the thing from doing this, because during startup transients, you're going to get some flow separation. That's going to happen. All right, here, I can show you another example. Here. Oh, look, it's time-stamped right where I want to show you. All right, take a look. Look. Watch the number 3 engine firing. So this is your turbines. Your preburner is spooling up. Your hydrogen preburner. Your high pressure hydrogen and high pressure oxidizer turbo pumps are spooling here. Now watch. Now note the shuttle engine has stiffener rings built into it. See? 1, 2, 3, 4, 5, 6, 7. See that? They have the stiffener rings built in. But even then, during startup transients, look. Yeah, see that? That's flow separation. That's bad. Now, I've been saying flow separation is really bad this entire time, right? Why is, it's really bad. It's bad for the nozzle. It's bad for everything. I can give you 1,000 reasons why it's bad, or I could just show you this. Watch the nozzle. See that? See the sproing? The sproing is bad. That's bad. You don't want that. Isn't the shuttle the closest thing to SSTO humanity has done? I would say yes. Yeah, absolutely. A 1.5 STO. Yep. See that? You get too much flow separation in the nozzle. You get the atmosphere trying to creep up in there. It's going to introduce vibration into your nozzle because your pressure is not uniform. Okay, I'm sure in RPE you've seen this diagram. Hold on. This one. I'm sure you've seen that diagram. You have to maintain uniform pressure throughout the whole design. If you don't, explosions happen. Your nozzle goes sproing. And when your nozzle goes sproing, yes, it does that. It probably doesn't sound like that, but hey, whatever. If that happens too much, right, it'll break. So they solved this problem with there's two tricks that they did with the shuttle engine. So the Vacuum Raptor trick, put a stiffener ring on it, 300 bar chamber pressure, send it, you're not going to have problems, okay? With the shuttle engine, right, they can't put a big stiffener ring on the end, so they integrated it into the nozzle design. These are all stiffener rings. That's what those are. And these are your bleed lines that go out on the sides there for bleeding your turbo pumps for like engine chill and whatnot, right? They solved that with those stiffener rings with the shuttle there, but the shuttle engineers actually had a very interesting idea to solve this during startup transients because you don't want to destroy your reusable engine, right? So their trick, their trick was to do this. All right, you want to see something weird? Watch this. So you have a regular nozzle like this, right? And then at the end, it just ends, right? You just, whoop, you have the rim of the nozzle and that's it, right? Usually, right, you're still expanding, right? Because you want that under expansion like what we were talking about. The shuttle engine's nozzle does this. It goes out and then it curves in. Like that. Curves in just a little bit. This is an over-exaggerated thing. It curves in. Why would they do that? Anybody know? One is to, obviously put some rigidity back into that nozzle. Yeah, they put... Now, I will tell you that... Yeah, Baron, I've seen this picture. We'll show that. I'll show that in a second. Actually, you know what? We could show it now. It's very interesting. Check this out. So look. The reason why they put that ridge in there is because they put the stiffener rings in, right? And this was happening. See the sproyoings? The sproyoings are no good. This is what happens if you let the sproyoings do their thing. See what I mean? That has not gone well. This is from shuttle engine testing at Stennis in the 70s. So they canted that thing in to catch the transients. All right, if you notice how that engine has flow separation, the flow separation, how it kind of propagates through, right? Right? Once it reaches right where the thing goes in a little bit, it catches it. And then, look, see? It all kind of comes together, right? Smart. Once again, it's there to put some rigidity back in the nozzle, but it's there to also push the gases in. Now, there are other reasons for this. They didn't just do it to solve the rigidity problems. They did it because this shuttle engine, and this is why shuttle engines are insane, it was because the shuttle engine is the first engine that can operate anywhere. It's not a vacuum. It's not a vacuum optimized nozzle, and it's not a first stage nozzle. It's somewhere in between, right? So down here, they canted it in because the shuttle engines are designed to work better up there than they are down here. The SRBs are doing the most of your work here. So they canted it in so they would get some basically force under expansion at lower altitudes. Does that make sense? Yeah, that's what I mean. The shuttle engine's nozzles actually curve inward at the very, very end. They curve inward to prevent this from happening down here. But you only got to prevent it for a second, right? Why does Raptor have such high bar chamber pressure? Long story short, it's to squeeze all of your characteristic energy out of methane. Yeah. So why? Okay, so the F1 had 70 bar and the shuttle engine has 200. Why such the range? Once again, it's to squeeze as much efficiency out, much of your characteristic energy out of your propellants. Or, well, would it be specific energy, guys? Out of your propellants? That's really important. Very, very, very important. Basically, blow up the gases better. A higher chamber pressure creates a bigger explosion. Or a bigger explosion creates higher chamber pressure. A bigger explosion burns off most of your gas. There's a reason why the shuttle engine's plumes are nice and clear. Because the byproduct of taking hydrogen and oxygen, mixing them, blowing them up, the combustion byproduct is H2O. It's just water vapor. All this thing is doing is shooting out steam at extremely high speeds. Think about that for a second. Is that weird or what? But that's because hydrogen is not very complicated and neither is oxygen. You combine those things together, it's really, really straightforward stuff. Building blocks of the universe stuff. That's why the plume is so damn clear, because it's just water vapor that's coming out of there. Crazy, right? Now with methane, with a Raptor engine, it's going to be a little bit different. You do have that whole hydrogen and oxygen thing going on, but you also, so methane is CH4. It's carbon and 4 hydrogens. Okay? And that carbon is gonna, you get a little bit of combustion byproducts coming out. But SpaceX is basically trying to solve that problem. They have solved that problem with high chamber pressure that burns off as much of it as humanly possible. That makes sense, dude? So it's a steam engine. Yes, Driados. Yeah, it takes steam and forces it through a nozzle. That's what it does. Oh, dude, it's beautiful. Couldn't they make expanding and contracting nozzles like what's used on jet engines? Yes and no, 1062. Yeah, you could, sure. But that you're flipping nozzle like, okay. You can do that like a jet, sure. All right, but you got to remember, you got to think about where a jet engine operates versus a rocket engine. A jet goes, what, from here to like 50,000 feet? The rocket engine goes to 350,000 feet. Making something that can change shape like that is extraordinarily complicated for trying to fly through that whole flight regime, right? And on top of that, maintaining a whatever chamber pressure you have. Basically, it's a trade-off, right? You can make the nozzle more complicated and make your turbine machinery less complicated, right? You could do that, sure, like what you're saying. The reason why nobody's done it is because it's easier to make turbine machinery better. Well, keep in mind, everything here is relative. That's all relative. It's easier to do that, but all of this is on a relative scale. Everything that we're talking about here is extraordinarily difficult for us mere mortals, right? So, you could make a nozzle that changes shape, sure. There are some rocket engines that kind of do what you're talking about, but kind of don't. A lot of them have some have telescoping nozzles, like an RL-10B2, but that's not doing exactly what you're talking about. You're talking about a nozzle that can change shape like this. Well, first of all, like once again, you're trading nozzle complication. A nozzle, which is already something that's very difficult to make, you're making it more difficult. When you could just make your turbine machinery better suited for the application. All right, it's easier to do that. Anyway. I did a little bit of, Baron, what's this? I did a little bit of trolling with subscale linear aerospike back in university. From my personal experience, I hated two things about it. Heat management is an absolute mess. Exhaust flow is wild if you need to run a sophisticated cycle like a tap-off or expander. It's the plumbing, dude. Plumbing on aerospike engines is difficult. That's why I was bumming when, like back in the day when I was reading about the RS-2200, how they got it working, right? And then they were just like, man, we don't need to use that. It's like, man! But if you do that design, it gets too complicated and you start hitting the second thing I hate about it. It's too complicated and mass creep is an easy hole to fall into. Bingo. Yep. The converged or the variable geometry nozzle with rocket engines is one of those things that just make your turbine machinery better suited for the application. That's probably easier. I'm not saying it couldn't be done though. That'd be sick, but that would probably be better in like an application for a jet rocket hybrid. But yeah, with a conventional like de Laval convergent divergent nozzle, I would just change the expansion ratio, which is what everybody else does. Like, because believe me, that's opening up a can of worms. And that's very easy to do with rocket science. All right, Rocket, what's up? Rocket engines utilize high chamber pressures to enhance performance by increasing the combustion reaction rates and efficiency. Elevated pressures improve thermodynamic efficiency, allowing more complete fuel combustion, higher exhaust velocities, and thus generating greater specific impulse. Higher pressures also enable Higher pressures also enable smaller combustion chambers and nozzles for the same thrust, increasing the thrust to weight ratio and overall rocket efficiency. Bingo. Variable nozzles exist, but the complexity is mad. The Sea Dragon upper stage was conceptualized to do this, but it's so hard to do. Imagine trying to sustain rigidity under dynamic nozzle variations and like 300 bar with a Raptor engine. Yeah, it's not that it can't be done. It's just that it's really freaking hard, and it's best with rocket science to not make it any harder than it needs to be. RDE Aerospike when? I freaking wish, dude. Mr. Rogers says, would you be my neighbor? Oh, anyway, Civilla, did that help? I'm always down to talk propulsion, guys. Propulsion is super cool. Aren't aerospikes better both atmosphere and vacuum over normal engines? Yes, RB. But you're trading that, so you're trading the gain, better efficiency down here and up there, right? Through transient ambient pressure conditions is what it's called. So that's a really plain English way of saying there's air down here, there's no air up there. Aerospikes can maintain efficiency no matter where they are, right? But they're a more complicated engine. So you'd really only want to do that. If your requirements for your design constitute an engine that does that. An engine that needs to do that, like VentureStar or an SSTO. That's a perfect example of where that application makes sense. An aerospike would not make sense on a two-stage to orbit vehicle like Falcon 9. That makes no sense. You're literally taking a two-stage rocket, which has more moving parts, right? And making it even more complicated by making a more complicated engine for a little bit more of efficiency gain. See what I mean? It doesn't make sense. But yes, yeah, that's what it does. No idea what you're talking about, but awesome. All right. All right. I have this poster. This was the prequel of the RS-25. It was designed to work at sea level. What the frick? What the heck? What is this? What? Hi, I want my shuttle engine to be more complicated than it already is. Okay, fam, say no more. I got you. Like, what? Bro, what do you... Oh, that's that XLR engine. Oh, this thing. This is what Sirat was talking about. Oh, God. Oh, God. What? Why the... What the frick are you do... Is that... What? Oh... Why does someone do this? Oh. Does the RL-10 on Atlas do that? No. No. The RL-10B2 on the ICPS does that. And previously the Delta IV. To be fair, they did build a working engine. To be fair to who? You made a... That's great. You made this. What? To be fair, great. You prototype. What are you using it for? We need that? No, we don't need this. That's what I'm trying to tell you. We don't need this at all. Please, no. The RS-25 won out over this. Thank God. Why would you do this? Oh my gosh. Good ornament for the good old Christmas tree. Oh my goodness. The jack screw on one side. Dude, rocket engines do this. And RL-10 B2s do that. But it's an RL-10, not a space shuttle main engine. Why would someone do that way? Why would someone do this to another person? That's awful. Does the RL-10 do that? No, I don't think so. Yeah, yes, it does. Are the RS-25s from Artemis 1 recovered? No. They burned up in the atmosphere. I'm reading this fast, I swear. Oh, dear. No. Oh. No. No. A step divergent nozzle. No. Why? No, yes, do it. Do it. That. Please don't be stepped. I think that's just the picture. Yeah, it is. Okay, thank God. No. Do not step the knot. Do not drink the chocolate milk. Do not drink the chocolate milk. Oh my word. Oh my sweet Jebediah Kerman. Why the... There was an attempt. There was an attempt, bros. Like, I see where they're going with it, but no. Oh. Oh, God. Oh. See, the shuttle does this, but for what it's worth, shuttle engines and SLS motors do this. They have 4 turbines. They have a low pressure hydrogen, low pressure oxygen, high pressure hydrogen, high pressure oxygen. They do that, but somehow they manage to do it and not be that complicated. That's complicated, man. Whoa. Sup, dog? I heard you like turbo pumps, so we put turbo pumps on your turbo pumps so you can pump while you pump. What the heck is going on in here? What the heck? Okay. All right. I'll get back into space news. That we'll look at that later, or never, or never. Please, ever, never make it. That engine may have worked, and that's cool that they got it working. I'm actually impressed that it works, but also, it worked, man. So what? So what? Why, dude? I just want to make all the things about this thing complicated. Let's just make everything complicated. Give it an extendable nozzle. Fine. Let's go. Transverse turbines. Let's go. Sure. Why not? 4 of them? Let's do it. Tri-symmetry nozzles? Sure. Why not? Bro. Bro. Turbo pump maxing. This engine is cursed, dude. This engine is cursed. It's open cycle. Oh. That's freaking cursed, bro. You see what I mean about trade-offs? You gotta, with propulsion, you gotta try to make it as simple as possible. But even the simplest solution is insanely complicated. So you don't need to make it more difficult than what it needs to be. That is an example of when you let engineers do their thing. There's engineers like, here, just you guys do whatever. This is what you kept. No. You're just a hater, man. What do you mean? What do you mean a hater? Why are you booing me? I'm right. This is crazy. Why would you do this? See, even Starbase Live agrees with me. That is a pretty nice shock cone right there. It's pretty nice. I'd be a little worried about your expansion ratio there. That's I really hope that engine is throttled down in this when this picture was taken. Because that is just on the verge of not working. No, you need to make it 100 times more complex with tons of more failure points, so for like that few extra seconds of specific impulse. Yeah. No, that's good. Let's do that. Even the shock cones want to be arrow spikes. RB, everywhere you go, you see her. Dude, I was in the tile store because I needed to fix something in my bathroom. The towel rack broke, right? So I was in the tile store. And they had black hexagonal tiles for like a bathroom floor. And they had it on swatches, right? So you pick up a swatch and it's a bunch of hexagonal black tiles. And I'm like, everywhere I go, I see her. I said that out loud in the middle of the tile store. Primo started laughing because she got the joke. I don't think the other people in the aisle got the joke. I'm pretty sure they didn't. It was funny. I'm not sorry. Everywhere I go, I see her. Would they extend the nozzle while it's firing? I don't know. I don't know anything about the XLR-129. I really don't. How pretty is your shock cone? Nah, it's not a good pickup line unless she's into propulsion engineering. You know what I'm saying? Bro, are we starting workers today? I'm only doing space news, Xanax, this week. Just because I have more things to fix around the house and around the shop. So it's only space news for now. Not much gaming this week. We'll pick up workers and Timberborn next week. I need an easy week that doesn't have much space flight going on. So I can fix things. My garage is thrashed, dude. Yeah. I'm only doing space news. Space news, rocket launches, flame trench, and GTA racing this week. It's gonna be like my first 40-hour work week and
Oh, this is space. I'm in space.
since 2012, I think. Sir Rat, give the sub to Rocket, go boom boom. Speaking of workers, it's 50% off on Steam right now. All right, cool. So, let's jump back into space news. So the L69 mission did take off, but we got some pretty big news today. Check this out. Real life stuff. Are you hiding a colonoscopy? No, I'm not old enough for that. You've been streaming since I was 4. Yeah, I started December 23rd, 2012. Yep. Check that out. Over the weekend, they stacked Core Stage 2. The Artemis 2 stack. Almost done. You had a week off when you were at Starbase. I would not call that, Mutter. Nope, wouldn't call that. Youth, enjoy it while it lasts. Yes, I will make sure to enjoy not having a doctor do that. Yeah, I'll enjoy that a lot. Yeah, I'll make sure to enjoy that. So is Jared getting sworn in, then launch? I don't know, but they seem to have picked up the pace. Now, NASA did, in true NASA form, check this out. We got some disgustingly nice pictures from the stacking over the weekend. There is the core stage vertical in the VAB. They picked it up off of its cart right here. And then there it is. Dude, look at this picture. These pictures are insanely high res. There it is. Moving out of the transfer aisle into high bay 3. Oh. Woof. What SLS cores will have RS-25s installed at the VAB? Core stage 3 and up. Kraken. Yeah, they're not installed at the VAB. The MPS is installed in the VAB. The main propulsion system. So the MPS is this, the white part, the thrust structure at the bottom of the core stage. They don't install the engines in the VAB. They do that in the SSPF, the Space Station Processing Facility. The reason why they decided to do that is because the MPS here is basically a space shuttle aft section in cylindric form with 4 engines. Because of this, because it's basically a spaceship, right? You're basically making a spacecraft here. Like, it's the back of a space shuttle. That's what it is. They opted to make to assemble core stage MPSs in the Space Station Processing Facility in a clean room environment to get less contamination. So, as far as where components are manufactured, not a lot of that has changed. The engine sections are still being built in Michoud, right, in Louisiana, along with the rest of the SLS core stage. They mate the MPS onto the core stage in the VAB, the MPS after it's been put together. The reason why they use the SSPF at Kennedy is because it's big enough to fit that thing in and out. So it was either build a new clean room at Michoud for engine integration or assemble your engine section where it's already going. So what they did was they retooled High Bay 2 in the VAB to be a vertical assembly jig for SLS, which is actually pretty cool. I wish they would have used SMART for the SLS engine core. Would have been nice to not throw away RS-25s. Yes, it would have. Yep. When do you think that we'll see this one get rolled out? Summertime. So here's another picture. Check this one out. Oh, this is from the top of the mobile launcher. You know, because I could see the crew access arm pin right there. Oh, hello, baby. That's a long way down. It's aesthetic as hell, RJ. So these are your pneumatic lines. These are your autogenous pressurization lines. That is your liquid oxygen downcomer. And this is raceway That's the raceway is basically carrying the wire harness. There's a lot of wires that go to engines down there. This is carrying the wire harness up the side of the booster to the top where, where the avionics package is. Not enough orange. Okay. I can fix that. I can fix it. Here. See? I added more. How long can SLS wait on the pad prior to launch? It can be out there a pretty good while, Nate. I don't know the exact number, but it can stay out there. Here. Does that help? Does it taste orange? I am not putting this in my mouth. Yep. That's a thing that I really didn't want to say out loud on stream. Thought I never would, but yet here we are. What am I looking at? Oh, well, that. Foam. Just said you wanted more orange. They should flavor the foam insulation. You have a piece of SLS foam? Yeah, of course I do. You don't? Don't bite, Sophie. It looks tasty. I tried it once, but it tastes bad. He said moron. Yeah, I wouldn't even touch it. I had a bad reaction to touching Sophie. Yeah, I don't. Yeah, I'm good. I would have had that reaction by now, Cyborg, because... I'm sorry, what were we talking about? Dude, look at the ground. You can see, so that's ground height. Oh. Would you just look at it? Would you just look at, oh, would you look at this? Did you sleep on it like a pillow? No. No. No, I did not. Oh, it needs to be pointier. It's not pointy enough. I've always loved Orange Rocket, Kate. Always loved it. She's a beast. Look at that thing. It just needs a better upper stage. You just gotta give it a better upper stage. Okay, like make the EUS if you want to, or put like New Glenn's upper stage up there. That's been my go-to. A New Glenn's upper stage up there would be primo.
Oh, this is Space.
Hey, Gods, what's up, dude? Thanks for the 5 subs. I appreciate it. Orange Rocket, very good. Look at that thing. A rocket for crew stacked in the VAB once more. Yep, first time since July of 2011. Would have loved to paint it SLS, though. But the orange is just so mint. It's like minty creamsicle orange, dude. You know what I mean? Oh, an S4B, Jim? Yeah, sure. Actually, an S4B on top of this would be great. That would be Sewer Rat with the 5 subs. That would be fantastic. I would very much like that. If we could just take an S4B and just make that. Just make that. It's stacked, dude. Look. Oh. Talking about Orion and SLS, this is what you found in your dad's garage. Sea Kraken with the bits. Thank you. Oh. What is the difference in diameter between New Glenn and SLS? So, Benji, SLS is 8.4 meter core stage diameter. New Glenn is 7. The stick. I'm telling you, man, it would have been a great rocket. It would have been a great rocket. Serious. This is a really good idea. Maybe not for crew, but, you know. Dude. You know, people saying, oh, no, you're just not gonna be, dude, reusable first stage, bro. Reusable. Okay, refurbishable, I'll give it to you. But also, hey, can you not get this back? You can get it back. It's just like Falcon 9, only not. But you still get your first stage back. I don't care what anybody says. Haters gonna hate. Article, you remember watching stick go up and down? What exactly happened to the Ares 1 test flight? The hardware? Anything above the SRB was, it was all a dud anyway. It was just a bunch of mass simulators up there. They did retrieve the SRB, but they had a parachute failure because it wasn't deploying from a nose cone. They had a parachute failure, so the bottom casing down here got all screwed up. We should have expanded the F1As on the first stage rather than RS-25s. RJ, I would like nothing better to put anything but RS-25s at the bottom of SLS. Here's where I'm at, dude. It sucks. I still am just kind of coping that those are actual shuttle engines that flew into space on the space shuttle that we're about to throw into the... Well, the SLS core doesn't even make it back down from the ocean, guys. SLS has like a not MEO insertion, but the Artemis 1 mission had like 1,000 nautical mile insertion, so that's like 1,600 kilometer apogee. None of that came back. None of this made it near the ground. Not even close. It burned up completely. With that being said, I really don't like the idea of shuttle engines burning up completely. That's not cool. But, he said, dude, where I would want my shuttle engines ideally would be flying on a space shuttle. Now, I'm pretty sure that ship sailed 14 years ago. So that ship sailed. I really wouldn't want Block 2 SSMEs sitting in a museum. I really wouldn't. They need to be flying. And if it can't be on a space shuttle, I suppose this is okay. I suppose. Block 2 SLS with smart reuse. That'd be pretty cool, man. It'd be pretty cool. I just wish the first stage made as much power as the Saturn V. The two SRBs pretty much do. 14,000 kilonewtons of thrust coming out of each SRB, dude. So that plus 4 RS-25s pretty much makes it's, what is it? It's 35 meganewtons. It's about in line. I know what you're saying, but this is close. RJ, the overarching point I'm trying to get at is that is good enough. Yeah, it sucks we're shooting shuttle engines into the ocean. I hate that. I hate it a lot. I'll trade it for a lunar program. That's the reality of that. I'll trade it for a lunar program. That's fine. It hurts. I'm not going to lie, especially being a shuttle aficionado. That hurts a lot. But it is what it is. Now, what's next for stacking? So the vehicle stage adapter, the LVSA, that thing is the next thing, which is in the VAB. There it is. There's a picture of it inside of the VAB. It's in High Bay 4, next to the SRB processing area. You could tell it's an SRB processing area because of the way it is. That's the next thing to get put on there. After that, you have the interim cryogenic propulsion stage, which is also in the VAB. This ICPS, this is a picture of it inside the Delta Operations Center at Cape Canaveral Space Force Station. They moved it. ULA moved it to the VAB. That's there. And then after that, down the street at the Neil Armstrong Operations and Checkout Building, the A2 Orion is ready to go. They put its fairing panels on, the fairings, the boat tail fairings on there. You just got to put the LAS on top of it, launch abort system. Besides Ares 1, SLS, and the shuttle, did those SRBs fly on anything else with less cores, perhaps? They were going to, because when Northrop Grumman proposed Omega, so because the SRBs are segmented, right? Northrop Grumman proposed for a national security space launch a segmented SRB, modular segmented SRB design. It was originally proposed under OATK, and then OATK and Orbital Science, well, Orbital Science was merged with ATK. Orbital ATK merged with Northrop, or was bought by Northrop Grumman. So what they wanted to do You know, the Space Shuttle SRBs are 4-segment. SLS is 5-segment. What they wanted to do is make a 2-segment first stage, and then a single segment second stage, and then a Hydrolox third stage for a national security launch vehicle with attachable SRBs. I believe these are GEM 63s, similar to Vulcan. And then, because you're using segmented SRBs, you already have a bunch of good data on 4-segment SRBs from the shuttle program. You have a 4-segment Castor 1200 first stage with a bunch of GEM 63s stacked around it, and then a Castor 300 second stage, which is just a single segment SRB. They proposed this, and they were going to launch it out of using a mobile launcher out of the VAB. That was their idea. It didn't get an NSSL Phase 2 Launch Services procurement contract, so Northrop Grumman said, never mind, we don't want to develop this. We'll keep flying our Antares 230 Plus variant with a Ukrainian core stage and Russian rocket engines first stage. I'll take plans that didn't end well for 600, Alex. Do the SRBs gimbal? Well, in Omega's design, yeah, one of those would have to have vectorable thrust for roll control, but yes. I really liked Omega. I really think Northrop Grumman should have kept going with it, especially since they made them. They made Omega. The first Omega cores were basically getting ready to go when they lost the contract. Yeah, they built it. Omega's first stage was already tested. I mean, it was tested poorly, but it was tested. Yeah. We watched this test live. The nozzle exploded. The nozzle exploded because of non-uniform heating from flow separation, because it's a slightly vacuum optimized nozzle, and they tested it at sea level. Well, sea level. They thought Ogden, Utah would be high enough to not have that happen, but it happened. Yeah, the nozzle exploded mid-firing. You saw Artemis 1 from about 3 miles. Nice. So is crew training what will be holding us up? I don't think so, Trey. Is there any difference between LAS and LES? LAS would be Orion. LES would be Starliner and Dragon. It's just what they call it, dude. They do the same thing. Now, the hardware design, Orion's launch abort system, is very different. It's very different than Starliner and Dragon's abort systems. Or, well, Starliner and Dragon, they're escape systems. It's just keeping up with the Joneses naming conventions. You could say LES for Orion. Everyone would understand what you're saying. On paper, they decided to call it a launch abort system. On Dragon, it's a launch escape system. On Starliner, with Atlas, it's a launch escape system. They mean the same thing, dude. Want to know something funny? Omega's tooling and second stage barrels are still in Michoud. Saw them a couple weeks ago. I think they should have kept going with it, Baron. I said it was a stupid idea. Now, the reason why I said it was a stupid idea to keep going with Antares, right, and switch completely to Omega, is because of the expanding satellite market. That was my cited idea at the time. You have something that can do 25 metric tons to LEO, you're opening up tons of contracts for future proliferated low Earth orbit satellite constellations. You think Jeff Bezos wouldn't have bought 20 of these Omega launches if he could have? Right? Oh, he absolutely would have. He bought Ariane 6 launches. Of course he'd buy this, right? He absolutely would. The second part about it is that Congress is already mandating you switch away from using Russian rocket engines. That was something that was implemented in 2014. So they would have had to eventually switch, right? And they didn't, and it came and bit them in the tailpipe. Or nozzle, whatever. What pad would Omega have used? 39B, RJ. 39B. They even started retooling a mobile launcher. Northrop Grumman leased one of the old shuttle mobile launchers and started putting a launch umbilical tower on it. Yeah. When they didn't get the contract, they scrapped all of it. And the mobile launcher. The shuttle era mobile launcher, which also launched Saturn V's. They scrapped it. Yeah, there's only one left. There was 3. The original 3 mobile launchers from the Saturn program, from the Apollo program. They converted all 3 of them to shuttle, and they've scrapped 2 of them. They scrapped the one that launched Apollo 11, by the way, if you felt like being mad today. Yeah, dude, they started building an LUT for it. Yep. Look at the Peacekeeper. What the what is this? What is that? No. What are you At least this is in a solid rocket booster, okay? At least that's an SRB, dude. What the nozzle is going on here? It's a triple expansion nozzle. Oh, this is what happens when your engineers huff too much engineering, okay? When your engineers do too much math, all right? It's possible. That's a thing, okay? Math. Not even thrice? Is it an ablative nozzle? Yeah. Most solid rocket booster nozzles are ablative spoiled. There's no other real way to keep them cool. SRBs put out a lot of cheech. We'll call it a little cheech. You put out a lot of cheech really, really fast. You know, if you have something like Raptor or whatever, or the shuttle engine, you can use your propellants to keep the nozzle cool, right? Because your propellants are cold. Solid rocket propellant is not cool. It's very, very hot. Yeah, can't use that. Nor can it move because it's solid, right? So yeah, a lot of SRBs use ablators. The shuttle used ablators. The shuttle RSRBs used an ablative nozzle that had to be replaced every time. Fun fact: they jettisoned it right before the SRB splashed down. Yep. If it's Cheech, where's Chong? Well, we already saw it. That's with that other engine. Anyway, sick pictures of SLS being stacked. That makes me very, very, very happy. See, this makes sense. It makes sense because it's solid propellants, right? Doing this with a liquid fuel engine, much less something with the complication of the space shuttle, is nuts. You are out of your freaking mind. Like, not really. That's really cool, but also, what are you, crazy? Yeah, I guess so, Edmana. Jeez. Yeah, because, you know, people that were sober didn't come up with that. See that thing up there? Too much math, okay? This is your brain. This is your brain on math. Any questions? Sane people don't make that, okay? Mr. Teller, where are you? Paging Dr. Teller. What's the red tank on it at the top? I don't know anything about the Peacekeeper, Sea Kraken, but if I'm looking at that right, it looks to be a hypergolic kick stage. For when you absolutely need to precisely maneuver your re-entry trajectory. Just build a bigger bomb. I mean, Tessa, the guy was a man of his word, I guess. When Brimo and I saw Oppenheimer and Teller were having that conversation, and Teller's like, just build a bigger bomb. Just build a bigger one. I'm like, I laughed out loud in the theater because I thought everybody would find that funny. Nobody else found that funny. And everyone ended up looking at me in the movie theater. They're like, what? Did I miss a joke? Why is that funny? I'm like, it's funny because that's what he did. That is what he did. That is what he did. Teller gave no fricks. He's like, I'll build a bigger bomb, whatever. We'll build a bigger one. You can make it as big as you want. That's what he did. He built the hydrogen bomb. That was his baby. He engineered the hydrogen bomb. And Castle Bravo is still the biggest nuclear explosion that the U.S. has ever made. And it was his bomb. He didn't carry the zero right and made a nuclear explosion that was way bigger than they thought. Yeah, oops. Turns out hydrogen, really good for that. Who knew? That is exactly what he did. That's why I found that funny. I was the only one that laughed. There was even a pause after it. Just build a bigger bomb. And then it goes back to Oppenheimer, and he's like, oh, I'm very conflicted about this. Teller's like, no. Just kill everyone in a nuclear fire. Obviously. It's nuclear war. It's going to be no winner. Just make a bigger bomb. Obviously. It's like... Oh, all right. Okay. That was a joke that was specifically put in there by Christopher Nolan for EJ. Yeah. I mean, guy's got a point. He deleted the zero and replaced it with an infinity symbol. Yeah. Look up Castle Bravo. It didn't end well. But basically, guys, okay, going back to SLS, all the parts for Artemis 2 are there. They're all at the Cape. Most of them are stacked in the VAB, which is pretty dang cool. Pretty cool, dude. Island? What island? Yeah. No island there. It just made a lot of glass. Fine. It's fine. Island? There ain't no island. What are you, nuts? There's never an island there. You didn't see it because it was there. It wasn't there. Get this man to an infirmary. Wait, no, that's different. That's a different nuclear thing. Anyway. All right. So let's jump through the next bit of the news. So Firefly posted this. Let's see what they're up to. On the road again. We're pumped to have Blue Origin's Honeybee Robotics hitch another ride to the moon on Blue Ghost Mission 3. This time we'll bring their rover to help explore the mysteries of the Gruthesian domes. Oh, Firefly is moving a rover for Blorgen. This is coming from Dave Limp. Our Honeybee Robotics rover will carry NASA's Lunar Vise investigation as part of Firefly's mission. It can excavate lunar soil by independently turning its wheels, helping to explore the challenging Gruthesian domes. Gruthheisen? Chat, you have to go to the Grashupen. Okay. The rover is equipped with an actuated radiator covers to effectively manage heat during the cold dawn and dusk, with the goal of enabling operations through lunar noon, the hottest part of the day. Cool, man. Cirrus, you have to be prepared for the Grashupen. How can you not be? Get my marching band. Last, what's up, Tessa? I loved how Teller just sat there in a beach chair with sun cream for the Trinity test. What a G. Now Long March 5. Now watch this drive. God, Kate, I was really hoping everybody forgot that joke, but now Long March 5. Frick. Now Long March 5. Dude, Max was saying like, oh, it's Hypergol. I'm like, no, it's not. Let me Google it. Oh, I'm in the wrong window. Or no, it wasn't Max. Who said it? I forget. Somebody said it. I was like, Long March 5. It's a verbal to Long March. Now Long March 5. It's so stupid. I love it. That's textbook me. Okay, that's cool. Firefly got more Blue Ghost missions set up there. I don't know how many they're contracted for off the top of my head. It's at least 3, because you know what you just saw. Okay, so next bit of space news here. Last after your shenanigans. All right. Do they have a picture of the radiator? I don't think so. Short Walk 1, 5. Slim Jim 5. Okay. Mong Larch 5. Short May 6. Best remember it before the end of the year quiz by Ryan. Oh, crap. Ah, crap. How many more launches can Intuitive Machines afford? They're contracted for 4 missions. Spoiled. Maya Space signs first commercial launch contract by Jeff Faust. Maya Space... Okay. All right, here, let's read. MySpace, a small launch vehicle developer spun out of Ariane Group, has signed its first commercial launch contract for missions launching as soon as 2027. MySpace said on March 20th it signed a contract with ExoTrail, a company that builds orbital transfer vehicles for multiple of launches of ExoTrail's space van vehicles. The companies did not disclose the terms of the contract, including the number of launches or their value. The space van vehicles will launch on MySpace's small launch vehicle currently under development. The vehicle, slated to begin launching as soon as 2026 from the former Soyuz pad in French Guiana, will be able to place 1,500 kilos in orbit when its first stage is expended, and 500 kilograms when the booster lands on a barge for reuse. That payload performance can be increased with the use of a kick stage the company is also developing. Watch it fly on Falcon 9. MySpace is Ariane Group's answer to Falcon 9, RJ. But because they didn't want to fully commit on like trying to make a new vehicle because Ariane 6 exists, they basically made a small sat reusable, like it would be like analogous to like a Falcon 1 that does what Falcon 9 does, basically. Like, that rocket is supposed to be reusable. In fact, they got a contract put out from, I think it's ESA. I think ESA put out the contract for, you know, new reusability things. Like new reusable vehicles. And like small sat launching. And then awarded it to their biggest defense contractor. Okay, I want to give people an example in the United States of basically what's going on here. Maya Space would be like if Boeing spun off Boeing Commercial Space. It made a spin-off of like Boeing Commercial Space called like Boeing Reusable Space. And then NASA or someone gave Boeing Reusable Space a contract. And Boeing Reusable Space is trying to build a Falcon 9 competitor. That's like the equivalent of what's going on here. It's a vibe. Average February 4. Yep. So, vaporware. The whole point of the contract, Cirrus, that MySpace got was to not do what Ariane Group is doing. That was the whole point. The contract that MySpace got to build this vehicle was supposed to incentivize commercial entities. I.e., you weren't supposed to give it to your legacy defense contractor that already has launch contracts. The idea is that contract was supposed to go to like RFA or ESAR or like PLD. Somebody, like, it was supposed to, the contract was supposed to spur the commercial market for rocket launches in the European market, so they awarded it to Ariane Group. Yeah. That's you're not doing that right. That's not how that's supposed to do. Seen the stuff in Norway with ESAR, of course. Yeah, they scrubbed. The weather. It turns out the weather in northern Norway is pretty unforgivable in March. Remember United Space Alliance before ULA? Yeah, the company that they made to run the shuttle program. Yeah, of course. That's not how you grow that. You're not you when you're hungry. Look at this photo. Yeah. Okay, what's this? Jenny. Jenny! Okay. I don't think fuel was stored in those radomes. Right. Sir, it looks like a giant Johnson. Yes, sir. Get on the Horde of British intelligence and let them know about this. Yes, sir. Anyway, ExoTrail launched its first space van vehicle in November 2023 on a SpaceX transporter rideshare mission, deploying a CubeSat from it several months later. The company says it has 3 more ExoTrail missions planned by 2027, including one to be a geostationary launching rideshare on an Ariane 6 flight in the second half of 2026. ExoTrail also signed a contract with ESAR in 2022 for multiple launches on ESAR's Spectrum small-sat launch vehicle. Now, speaking of ESAR, they did scrub. ESAR is looking to do their inaugural launch on their Spectrum launch vehicle in Doya, in Norway. They did try to launch this morning and didn't launch this morning because the wind. The weather in Norway is very unforgiving, which is pretty cool. ESAR is a German commercial launch provider. Pretty cool. They're competing with a couple of other commercial entities in the European launch market, like Maya Space and Rocket Factory Augsburg, which I like RFA. I like ESAR. They're pretty cool. I like what they're doing. Good stuff. And then PLD out of Spain, which that's cool. It's cool to see a commercial launch market expanding into Europe. That's cool, man. That's good stuff. See last. What is this? Oh, what the hell? What the hell is this? That, bro, just make a nozzle. Just make a nozzle. Just make a nozzle. You don't need to do this. Just make the nozzle. Just make the nozzle. Just put the propellants through like everybody else. Oh, for the love of God. It will gimbal the nozzle. I can read. Thank you very much. Just this isn't hard enough. Dude, you know how many times this thing's gonna blow up on the test stand? I mean, I'm here for it. That's cool if they get that done, but oh my goodness. Why would you do this? Why would you make this happen? Why would someone do this to another person? That's not how this works. Just seriously, is making my head hurt. Making my brain hurt. Not making brain go hurt do good. More. It'll blow up every time. Yeah. Yeah, it will. Okay, so MySpace has their contract here. Let's see. Relativity posted this today. Say what you will, at least they aren't lacking in ambition. Dude, if you decided to make the most vanilla rocket engine of all time, Admana, for the most vanilla of launch vehicles of all time, that's still extremely ambitious. I don't know what this is. We're beyond ambition. We're ambition cubed. So ambition, just with 2 letters or 3 cubed. Like that. Ambition maxing. Yeah, Silent. I'm going to go ahead and give that one a no. We should probably not do that. Anyway, so relativity who kind of, we weren't sure what they were doing. They released a 42-minute video 2 weeks ago about how they're basically starting to build Terran R. And now we have a video about their launch pad here. Well, it's a short one. It's a time-lapse vid, I'm pretty sure. But look at that. They're pouring a lot of concrete. Wait a minute. I know that guy. I know that guy. That's weird. This is awkward. Especially if that person's watching this stream. I see you. I know that guy. That's pretty cool. I know that dude. I know that crane. I've touched that crane. Nice. Putting some tankage on there. He ain't here? Well, that's a shame. Yeah. Definitely know that guy. So relativity is, yeah, it's all right, Creeper. Don't worry about it. If you know, you know. Let's just keep it our little secret. We know that guy. I know people who operate cranes. Let's just say that the crane operators like watching this stream, and we'll call it a day, okay? So, relativities, this is Complex 16. You could see that's the Terran 1 launch pad that they refurbished and then used once. And then there's the Terran 1 HIF right there that they built and used once. And you can see they're working on a new vehicle, horizontal integration facility, and a new flame trench for their pad, for the Terran R vehicle, which is pretty cool. We're still a ways away from getting any testing here, but that's still a lot of concrete to be poured right there. We indeed know who that is. We do know who that is. Yeah, see that dude just chilling right there? I know that dude. That's funny. I know that guy. Anyway, good stuff. I wish them all the best. Oh, guys, I don't know if I told you guys this. You remember if you were here for the Space News where we watched Relativity's stream? Not Relativity's stream, where we watched that video of why they were using such a wide cutting face for their billet, for their barrel segments. You'd use a wide... I asked my dad about this, who's a machinist, and I asked him why such a wide cutting face. And he said they're doing that because they think they can do it quicker. That's the reason. So expediency is the reason why they went with a wide cutting face for their billet. Just in case anybody cares. Because relativity was... So when you build like rocket barrels, like say garden variety rocket barrels, right? You take a thick sheet of aluminum, right? And you drill stringers into it with an end mill, right? You just... The end mill just does this a bunch of times and it makes a square, and then you could basically make a grid, right? You make a grid, and then you put it through a metal brake, and it bends it, and then you weld a bunch of those segments together, right? Like this, right? You weld a bunch of them together, and you make a barrel segment. That's how they make fuel tanks. Falcon is made like that. Vulcan is made like that. Atlas is made like that. SLS is made like that. The Space Shuttle external tank was made like that. Everybody does this way, to an extent. Maybe not the shuttle external tank, but you get what I'm saying. It depends on the version, if you really want to know. So, they are trying to make barrel segments quick. That's why they have such a wide cutting face. I like how a bunch of these Missile Row released companies have kept the blockhouses. Yeah, me too, man. That's right, it goes in the square hole. So, we theorize that relativity is, you know, trying to build stuff fast because they actually contracted out their tank dome design. So they're making their own barrels, but they're not making their own domes to the tank. What I mean is like a fuel tank is pill-shaped, right? So you have a half sphere here, and a cylinder in the center. They're not making the half spheres. They're making the cylinders only. It's a cylinder. And then they are actually working with Arianespace to make the domes. And they want to scale to Falcon 9 flight frequency. Is it just me? Is your beard starting to go gray? It is. What's up, Urban? Domes. Theme of today's stream. Domes. My neighbor's been in the rubber room under 39. Cool. Article, that's neat. Smarter Every Day has a tour ULA that shows this production really well. Yeah, ULA is like willing to show it up close, which is actually super cool. Welcome to the club. It ain't the age, boys. It's the mileage, okay? Anyway, speaking of concrete pours, we have some pictures from RGV aerial of the trench. SpaceX did complete their first pour, right, into the flame trench here. They completed it. I actually have the specs that were compiled from by Creeper here. Total pour time just for the floor. So they've poured this segment right here, this piece. They only poured the very bottom this time. The total pour time just for the floor is 27 hours and 20 minutes using 303 concrete trucks. Concrete trucks hold 10 cubic yards. So that's 3,030 cubic yards of concrete. Just for the bottom of this trench. Whatever helps you sleep at night. Oh, shut up. Shut your teeth. Crazy. That was just for... That's just for that. Which is pretty rad. That, dude, this thing's going to be hefty. 252 cubic meters. Yeah. To convert yards to meters, a meter is 3/4 of a yard. Yeah, just for all the metric folks. Yeah, that's a lot of cubic meters. What's going on to the right of the trench? From what I've been told, Mutter, those are water lines. They're putting in the pad deluge plumbing is going to end up over here. Please convert that to feet. Nobody uses yards. A yard is 3 feet. That's a cubic hole. It's also very square. That's right. It goes in the square trench. Here, let's see. Once again, this picture's coming from RGV aerial. Let's take a look around. Look around. I've got lots of stuff. Interesting. Huh. Ten cubic yards are 7.65 cubic meters. That's what I mean. About 3/4, William. It was an estimate for if you're doing quick math, but yeah, there's your precise calculation. You can embed there for the trench wall sections. Yeah, the walls are going to go right there, interestingly enough. That is a big trench of a large size. Agreed. Commodity lines are right there. Looks like they got those pipes. Oh, nope, they end right there. I was going to say, looks like they got a lot of them made, at least in this segment. It looks like they're running pipes through modified drainage culvert, if I'm looking at that right. Interestingly enough. About 350. Gambling, yeah. So you can see they got the pour going down there. Are they still pouring? Let me take a look. Nope, not pouring right now. Let me give SBL a quick refresh there. Also, the high bay has started to get disassembled. They took the gantry cranes out of there this morning. This is a telescoping crane right there with a a jib mast luffing attachment. That's this kind of latticey bit at the top of the crane right there. That's for moving pretty heavy stuff further away from the crane. That's what a luffing boom does, which is pretty cool. Pretty sweet. Yeah, not pouring right now. Crane nerd. Yeah. Yeah. Guilty. Guilty. Yep, very guilty. That crane also stacked Starship Mark 1. Oh, really? Cool. It's a Liebherr 11,200 in the T3YVEN-54 configuration. And hold the fries. Yeah, guilty. Yeah, I'll do it again. Guilty. So Chrome Kiwi did a little bit of a Chrome Kiwi did a little bit of a render. There's those Nelson studs right there. Guilty. I'll do it murder. I'll do it again. I'll freaking do it again. Interesting. Interesting. I noticed this from RGV's picture. Look, the let's call it the tower side wall. The tower side wall is offset. See what I'm talking about? Meaning there's going to be something back here. I mean, Creeper and the rest of the pad rats that watch this, you guys tell me. That's probably going to be where the plumbing is for the water systems, if I had to guess, because considering the trench for the water pipes is like right next to it. So if this is a Chrome Kiwi render, it looks like they're going to run the pipes in here for the flame bucket, which is interesting. Viewing platform? For viewing what? What are you viewing from here? The only thing you're going to view here is death. No, they're going to run the water pipes back here because once again, it's using a flame bucket. So a flame bucket is a deluge system that's in the shape of a flame deflector, and that's going to go right here. One-time viewing platform. Yes. RGV was thinking it was deluge plumbing, both for the pad and the bucket. Yeah, that's my guess as well. Considering the trench for the water lines that's going right here. Dude, RGV is the best, man. Look at these freaking pictures. They're so good. Just fill the flame trench with water. Yes, the Sea Dragon solution. All right. Cool. Let me just see. So yeah, that's really what's going on here. That's what's going on today. Then it doubles as a pool. Just think of all the mosquitoes that can fit in that trench. Oh, why you gotta ruin it like that? Done by the end of the year? Trey, I said the pad's gonna be done in the summer. I think the summertime is pretty damn fair. Yeah. Could you please do a very quick recap on the important space news for the day? I couldn't join for the start. ESAR scrubbed their launch attempt, Lava Eagle. The L69 mission launched this afternoon, and it worked. It was awesome. Everybody's making 69 jokes because it was the L69 mission. SLS Core Stage 2 was stacked in the VAB over the weekend. And SpaceX has completed its first of a bunch of pours for the flame trench for Pad B. All right, Everest. Yep. What's the metal on the far left? This stuff right here? That is the... Okay, I have theories, Seacrack, and they're probably wrong, but I have theories. They're calling it the gantry. I think the deck of the OLM is going to be right here. So the top of the OLM is going to be in this area. right? And it's going to hang over here. And this, I think, is areas for the plumbing. It's basically access into the OLM for all the commodity lines. So liquid methane, liquid oxygen, which are coming through here, nitrogen. And then I did notice something a little strange. I did notice that if you look at the spacing on these, and, you know, I don't know, could be wrong. I'm just taking a guess. If you look at the spacing, I noticed that the outer two diagonals here are close to each other. And then the inner two are kind of close to each other, but there's a gap. So you have a group of two here, a gap, another group of two with a wide gap, and then another wide gap, and then a smaller grouping of two. That tells me that these are going to, something heavy is going to be right here and right here. Because you wouldn't put these supports closer to each other unless it was lifting up, unless it was holding up something heavier. Now, what that is, dude, I don't know. It looks like they're also pouring concrete here as well. They have a corrugated metal floor here that they're pouring concrete onto, so you can make concrete floors that way. I have no idea why you'd do that. I thought there would be like pipes coming up here, but clearly there isn't going to be because there's no holes in it, right? Unless they make a hole in it, who knows? But yeah, this gantry is where all your commodity lines are going to go into the OLM. I just don't really have a good idea how they're going to do that, but you get the idea. You would drill holes after the pour. For something this wide, Spoiled? For something that's like a half-meter wide? You think so? Do you recall when they will be doing the demo mission for the thermal and nuclear engine? 2026 is when the last thing we heard, John. That's the dock for the UNSC Starship. Oh, okay. The fuel lines are going around the trench. The gantry will carry two quick disconnects. One for fuel for the booster and the other for pneumatics. Yep. Fram 2 is next Monday. Yes, that's right. That's another good bit of news. We should probably share that. The Fram 2 mission, which is the first polar orbit mission and also the first commercial polar orbit mission because it's never been done before. Crew completed its training this week, early this morning. The Dragons supporting their mission arrived at the hangar at 39A in Florida ahead of the next liftoff attempt on the 31st. That's the Fram 2 team. This mission is a polar orbit mission. No person has seen the North Pole or the South Pole from space, like directly over it. This is the first mission that's going to do it. Yeah, that's never happened before. It was supposed to happen in 1986, but somebody decided to ruin that. Sorry. Anyway, yeah, this mission is going to be on Monday. I will cover the whole thing. Oh, yeah, we'll cover that whole thing as much as we can because it's awesome, obviously. So Falcon is going to do that dog leg again. That's the only way I really see it going into launching people into space. If you're launching out of 39A, they can't launch north. It's got to be south. And that dragon has the cupola on it. Sweet. How long is that mission supposed to last? I actually don't know, Comus. Throughout the week, as we get more, I'll do some research into it throughout the week, and I'll try to get you some details in the subsequent space newses throughout the week. T0 is 11:20 p.m. Oh, I'm in, dude. I don't give a frick when it is. We're watching it. What's the name of that dragon? That's Resilience, Kai Fox, if I'm understanding that right. Yes, it is Resilience. It's the same one that flew Inspiration 4 and Polaris Dawn. I think it's 5 days. Go north, coward. I want to see it in Ohio. Yeah, let me just dial up, Kiko. I got him on speed dial. I'll just tell him, no, launch it north, okay? Frick all your training. Launch it north. Hey, yeah, and Crew 1, I think. I know it did one crew mission, and then Inspiration 4, and then Polaris Dawn. You need to see the amount of recovery ships and facilities to support emergency abort locations going south. Oh, yeah. That capsule has a cursed toilet, by the way. 3 to 5 days on orbit. Thanks, Mutter. Thank you. Yeah, crazy, dudes. Crazy. What a nutty mission. All right, dudes. That's going to do it for space news, I think. I think I got everything. Unless there's anything else you guys want to talk about. Have you reviewed Atomfall yet? I don't know what that is. Inspiration 4, open the floor panel to find a puddle of piss under it. I do remember that, Baron, yeah. No Dream Chaser updates? Not that I know of, Ike. I haven't seen much. I'll review again. What's your opinion on Kitten Space Agency? Kai Fox, if Dean permits, I'll ask him to cover the town hall. Guys, there's a Kitten Space Agency town hall on Thursday. Basically a status update thing that Dean is going to stream. Kitten Space Agency is kind of the spiritual successor to the Kerbal franchise. It's being made by Rocketworks in New Zealand with a bunch of ex-KSP developers. There's a huge update for it on Thursday. With permission, I gotta ask, I gotta be sure, I will cover it. Kai Fox, I think KSA is trending in the right direction. I do consult on that game. Full disclosure. They do ask me questions about stuff from time to time. So, yeah, full disclosure. Siret, I'm sad I was on a train when the XLR 129 conversation was happening, but I have to say, it was not developed as a shuttle engine. It was for a CIA hypersonic super high altitude SR-71 replacement. It was silly. That engine belongs in the garbage bin. Siret, it's very cool. But why? It's like the guy that put the Dodge Viper engine in a motorcycle. You have a motorcycle with a V10. Yeah, that's super freaking cool. There is no practical application for that. And, you know, the V10 motorcycles, you know, you built it just because it's cool. But also at the same time, the rockets are about practical application. That very much varies into your design philosophy for rockets. That's really important. So I'll say again, what the heck were you thinking when they made, I mean, that's cool. Don't get me wrong, but no. Will Starliner ever fly on Falcon 9? I don't know, Troy. Maybe. Wouldn't that be something, dude? Wouldn't that be something? Is NGAD F-47 relevant? Did you discuss it? I don't know anything about it, Arsenal. It has canards, so I kind of hate it. Oh, very nice, Nova. Very good. Did we ever figure out why KSP2 failed, not just speculation? Might have been covered already, but I missed it. Thoughts on Elon's statement about getting Starship in service on a weekly launch cadence by next year? I saw that, Badger. It's in the realm of possibility, just a little bit unlikely. It's in the realm of possibility, though. That is, I don't think weekly. I think they could nail monthly next year. Sure. Maybe even sub 2 flights a month. Sure. Yeah, I think that could be possible. It's possible. Yeah, Elon actually gave a space update for once on X. Like, that seems to be few and far between. That hurt to say that. It used to be all the time, but he said that they've figured out the version 3 version of Starship and they're going to start implementing it. Remember when I said that something on Block 2 was most likely designed for, like, Raptor 3? It was most likely designed for a future variant or a part that doesn't exist yet. There you go. 619, what is your last? What's up? EJ, you'd be proud. All your teaching allows me to call out some incorrect information on an Instagram reel. Rocket exhaust being plasma. My bullcrap meter went crazy. Yeah. Who said it's plasma? Oh. Instagram, not even 1619. Jeez. Tessa, what's your last? Atom Fall. Oh, okay. It's an action survival game developed and published by Rebellion Developments. It's set in an alternative history 1960s where wind-scale nuclear disaster turned much of northern England into a radioactive quarantine zone. You what, mate? Oh, you got a permit for that Fallout, mate? Cool. I'll look into it. What is this? Do I want to...
Stream back to Earth from a moving rocket booster. But the request documents for the FCC can, and it's pretty interesting. SpaceX live streams their launches from the rocket. How?
I really wanted to know this, so I went to Stack Exchange, and someone named Bob Jacobson answered this. Anytime you're doing anything over radios, you have to file paperwork with the FCC. So it turns out SpaceX filed the plans for how they were going to do the video. They have these special digital video transmitters that broadcast on 2 frequency bands at the same time by a company called Quasonics. It's right around 2 gigahertz. It's not 2.4 gigahertz, right? And they beam down the video on both channels at once. So it's a real problem on a rocket, both because it's moving fast and those flames coming out of the bottom of the rocket are plasma. They're making static, radio static. So it's...
That's right. It's not plasma though, but they do screw up signals. It absolutely is a thing. That's why do you guys remember like drone ship landings back in the day? They always would get an interrupted signal right when the rocket came back down because the vibrations. I mean, it's more about the vibrations than anything, but yeah, that's not the right way to say that, but yeah, it does screw it up a little bit. It's more the antennas vibrating though, not plasma. That's not that just, yeah.
It's really tough. So to make sure the video gets through, they send...
I mean, if you really want to, Raiden, like you could, like, okay, all right, 619, to be very clear, you can say it that way. It's just not really the right way to say it. I wouldn't call it plasma. I wouldn't. It's just, it's hot gases. But there is some residual ionization that happens. The plumes do screw stuff up. He's not wrong. That's what he was trying to say. Like, you know, just calling it plasma is kind of like, eh. You know, in the context of this conversation, it seems, the way he infers it, it seems like the engine is spewing out plasma. No. No. But he's not wrong. The engines do screw with the signal. He's absolutely right. And I know what he's going to say. I know he's going to finish it. That's why they broadcast twice. Seriously, they have 2 transmitters on there, and both of them transmit a crappy signal, right? SpaceX takes those 2 crappy signals and weaves them back together. Yeah, that's what they do. That's right. He's correct.
Send it twice. And so they're receiving on both bands and putting it together. So any bits that get through, they combine. And that's how they managed to get that video.
Redundancy.
That's
yep.
What the BBC is using.
Right. Nick Garnett, we interviewed him a while ago.
Yeah, that's what they do. That's how we get spoiled by these signals. SpaceX transmits it twice. Yeah, they transmit it twice, and then they have a way to basically stitch it back together in real time. It's actually not that far off from like what a live view does. You guys know the live view packs that we use for live streaming that we use to stream the road trips, right? It basically sends it 3 ways over the signal. Like if you have a Starlink plugged into your live view and you have 2 mobile hotspots, it'll send it out 3 times, right? It'll send the same video out 3 times and then it'll weave it back together on an RTMP server. It's super cool. That's what SpaceX does, but they do it from on a freaking spaceship flying around. That's pretty cool. But yeah, it's not, calling the exhaust holy plasma is not really the right way to say it. A better way to say it would be there's ionized gases coming out of the rocket engines. Some ionized gases coming out. That does screw with the signal. That's right. That's correct. Ionization messes with the signal. That's why plasma like during reentry. you know, it's hard to get a signal with Dragon because yeah, those transmitters are trying to transmit through through ionized gas. It doesn't work. That's hard to do. Yeah, pretty much, Cornelius. Yeah, it's pretty awesome. NRL second stage going through passivization. We saw that, Vargon. That's pretty cool. Help, I bought Star Citizen on Saturday and I can't stop. That's your own fault, RB. There's a very good reason why I don't play that game. The stitching is done by the protocol itself. Yeah, it's the same idea. SpaceX isn't... Don't get me wrong. Yeah, all systems, I should clarify. SpaceX doesn't have like a live view strapped to the side of Falcon 9. No. They're doing something a little bit different. It's the same concept. You mean Star Citizen. Ooh. Woof. Cable modems do the same thing. They do channel bonding to get more bandwidth. Yep. Any thoughts on the new gasoline 6.7 from Cummins? I did not know that they were making that. Cummins making a gasoline engine is... I don't know how to feel about that. Oh, that's very strange. That's very strange. Didn't we see live view on the SpaceX screens in a Starship recap video? I think that was for tower cameras, Goatman. I think that was for cameras that were on like the launch pad. I don't think that was for the vehicle. But you're right. I do remember we did see a live view logo in a SpaceX recap. You're absolutely right. Maybe they do. Who knows? I'm pretty sure they don't. 300. What is it? Is it an inline six? That Cummins motor? What? Really? Really? Wait. What? Okay, just give me a second. All systems. There. Cummins is making a turbo inline six 6.7 liter engine. But how much does... Okay, let's be real. We can't afford it, but also just... It's a gasoline 6.7. What the hell? Dude, that's cool. 300 horse, 660 foot-pounds. Dude, someone's gonna weasel 1,000 foot-pounds out of this thing. Dude, 300 horse. Whoa. With low complexity air handling, no def required, no active regens, maintenance and operations are simplified. It's easier to make a freaking gasoline engine. It's stupid. What the hell? This is a thing? Dude, this is sick. It's a freaking gasoline B series. Are you kidding me right now? What is it? Dude, that is very conservatively rated 619. There's no way. Dude, someone's gonna crank 1,000 horsepower out of one of these things. I'm calling it now. Cause dude, like think about it. 300 horse from an engine that's basically the same block as the diesel. Diesels are designed to withstand a much higher compression ratio. Someone's gonna weasel 1,000 horsepower out of this thing. I'm telling you right now. Dude, that's sick. That's really cool. Talking about engines, Ferrari dropped this patent out of nowhere. Can we just limit that entire sentence, Baron, to talking about engines Ferrari dropped and just... We don't need the other parts. We're good. Well, yeah, they'll design a head for it, but if the block is the same as the diesel, you're gonna be able to beat the snot out of this thing. It's pretty cool. They have a huge emission regulation change, especially for diesels in 2027. Okay. Is it underweight though? I don't know, dude. Your work truck has a B series Cummins in it. Nice, nice, nice. Will that fit in the 250? Sure. Wouldn't that be sick? Wouldn't that be sick? Oh. A crossflow inline six. A crossflow inline six in my truck would be sweet. But let's be real. We can't afford this. I can't afford this. It'd be sick, though. Need it in the dually. In the dually, boy. Ernock, get more money. Then we'll put it in. They just designed a weird oval piston with a single connecting rod. Interesting. Oh, yeah, I've seen that stupid thing. Yeah, I don't know. Ferrari needs to look in the mirror. Let's put it that way. Every race that I watched was just a terrible disappointment this weekend. F1 was disappointing. The NASCAR race, very disappointing. Just disappointment after disappointment. What does medium duty mean? Anderson, that means trucks basically from like a 3/4 ton truck all the way to like a 2-ton truck. Somewhere in there. Ferrari won the sprint race. Great. Gold star. Tell your team to follow regulations. I shouldn't have to tell them that. On the Ford 6 forum 20 years ago, there was a guy that had a crossflow Ford 300 on a dragster. It was a Ford experimental head. Dude, if they ever crossflowed that 300, now that Ford would have made the most insanely durable engine of all time. Meaning it's someone's going to put it in a Mustang. Yep. Anybody ever driven a 350 Olds Delta 88? I've never driven those, but I've heard about them. Article. Turns out when you take a gasoline engine and try to make it use diesel and you don't design the heads correctly, the high combustion ratio of a diesel engine blows head gaskets very easily. That's weird. What is a crossflow in internal combustion engines? Okay, a crossflow head, Lava, means your intake air comes in on one side and your exhaust comes out the other side. That's the quick way of saying that. As opposed to a reverse flow head. See, Ford's inline six that they put in trucks up until 97. So it's a 4.9 liter inline six is a reverse flow head. So here, I'll pull up a picture of it for you. This is off of some dude's build. So that's a 300. It's a great engine, dude. These 300s are impossible to kill. But you have your intake exhaust, intake exhaust, intake exhaust, intake exhaust, intake exhaust, intake exhaust. They're right next to each other. Because, preheating your intake air is, really good for combustion efficiency. It's not. Yeah, it's not. But, yeah, still cool. They're great engines. If Ford gave them a dual overhead cam head or even a single overhead cam head that was crossflow, meaning intake on one side, cold on one side, hot coming out the other side, like every other inline six from the 90s, it would have been a pretty damn good motor. I mean, they're still good motors. They're just like those Ford inline sixes are impossible to kill. You cannot break those things. I've seen videos on YouTube of a kid that tried to do this. He tried to make this video. He's like, I'm going to kill this 300 inline six today. Runs the thing with no radiator, redlining it. And it's just, and then it overheats and it seizes, right? And then the kid comes back the next day. He's like, all right, I'm going to try to, let's see what the damage is. Started right up. Yeah, I don't know what they did with those motors, but I know the answer. Cast iron. Everything is cast iron. So the motor's super heavy, but it's also super durable. You can put a lot of heat into a casting. A lot of heat, because castings are extremely dense. That's why the engine's hard to kill. It's hard to overheat it, because the casting just tanks all the heat. Have you ever seen the Thor 24 semi? Nope. And Ford of Europe made cross flows all the time. Yeah, I know. I don't... That's strange, Aaron. Is your background a mechanical engineer? Booms, I'm self-taught when it comes to engineering. I'm a 3D artist by trade. I can make like CAD systems work and stuff. But yeah, I'm not an engineer. I just play one on Twitch. Oh, that thing, Dr. Death. Yeah, 3,900 horsepower. Yeah, okay. Ferd Australia has the Barra. Yeah, Barra heads don't fit on the 4.9 though. Where does Starlink come into this? Yes. Dude, I was in a freaking Walmart this morning looking for a specific thing. I saw Starlink. There was a Starlink end cap. It was very strange. Like, you can go to Walmart and just buy Starlink, which is just... That's weird. Cool, but weird. Oh, I could be quiet. Nice, that's cool. Right on, man, right on. Yeah. I just like mechanical things, dude. I just figured out that I really like mechanical things after I went into a lot of college debt back in the day. So, you know... I'll just stream stuff on Twitch. It's fine. The Rover SD1 with the Griffin motor, 37 liter. Yeah, I know about that. Would you like this? I don't know, maybe. If it's a steam engine, yes, I will. Yeah. Oh, yeah. Yeah, I like that. That's pretty cool. Look up Pat Nahan, Ford 300 inline 6 on YouTube. Different car. Sounds wicked. You are my favorite fake engineer. Thank you. You still hop back in. It would be really cool. You know, Sea Kraken, dude, if I make enough cash and pay off, if I finish paying off my student loans, dude, I'll do it. I'm serious about that. I'll do it. If I'm still streaming and I get those things paid off, I will do it. I'll pull the trigger on it. I need to go back to learn math because, like, dude, I'm okay at math. I can do it. I would want to start from scratch, basically. My high school education may have well has been in another life, dude. I really want to start from scratch. You know what I mean? But I would do it. I'm serious. I don't care if I'm like 45 with 2 kids or something. I'll still do it. I'd love to. It doesn't bother. Like, I'm just biding my time, dude. But I'm persistent. That's what gets you far in this world. Just be a persistent person. Just keep going. When you're going through hell, keep going. I think Patton said that. All right, Bet, here's your start. Thank you. You should be able to get an engineering degree with enough hours in Kerbal Space Program. Berserker, I have 15,000 hours in KSP. Does that help? Dude, if I could use that to parry for a degree, I could get like 4 degrees. You know what I'm saying? You know what I'm saying? What's 1 + 2? Potato. It's a good start. All right, cool. They started selling Starlinks nationwide late last year. It's so weird, Trey. Yeah. Hey, Eric, what's going on? University's rocketry team kind of went viral this weekend. Was it viral for a good reason, Eric, or viral for a bad reason? Can you generate spreadsheets for calculation tools? If so, you got the first part of modern engineering down. The next is looking up information quickly. I can do that. I got a lot of information stored up there. Your dad did it, 40 years old, went back to school and worked engineering for 20 years. Never too late. I never said it was, guys. I said, dude, I started streaming with the intention of, you know, making enough money to go back to school for engineering. That's still within the realm of possibility. I'll do it. You know, I just got to get to the point. We'll get there. I ain't worried. I'm persistent, guys. I ain't going nowhere. The Frenchtown Flyer is a 306 dragster I was thinking of. Frenchtown Flyer. Live stream engineering school. Oh, boy. Pretty sure your math is better than Ferrari math. Well, yeah, of course. We're talking about aerospace engineering, not clown fiesta math or whatever the heck is going on in Maranello. That honk honk, you know, like, honk, you know, like, dude. Oh my God, it's so bad. Yeah, I'll do it again. I'll get disqualified again. Yeah, of course. IRIX O-Class motor blew up. IRIX O-Class motor blew up 30 days before the testing deadline, so we made a show of it and asked for donations. Oh. Cool. Well, not the engine blowing up part, but how do you even become good at math? Do it. Do it. Math is a language, all right? It's a language. Like Spanish or French or Russian or whatever. It's a language. The only way you get good at a language is to speak it. Well, write it, speak it, hear it, etc., etc. Right? That's the only way you get better at it. The only way you get good at math is if you keep doing it. Also, ¿dónde es que el metro? La ensalada pica mucho. Me gusta los zapatos. Right? Sí, bien. Gracias. Just looked. I bought KSP in 2021 and have 7 hours game time. Oh, you're good. You're good. You should work for NASA. Sorry. Please stand clear of the doors. Por favor, manténgase celado de las puertas. On behalf of the cast of the Walt Disney World Resort, welcome to the Magic Kingdom. You forgot, ¿dónde está el baño? Mi estómago. No, me duele el estómago. ¿Dónde está el baño? It could be enough for... I'm not saying that out loud. No, RB. That's not what I said, Plias. Trey, you're joining your university rocket team. For some reason, they do hybrids. Cool. They're going for a hybrid space shot in 2026. Cool. Neat. I have a bad case of diarrhea. Awesome. All right, dudes. Well, I think we've sufficiently covered the space news today. So, I think that's going to do it. The plan for the rest of the night is me going and finishing working out there. I hope you guys enjoyed Space News. It's a good 2.5 hours there. Timberborn for After Hours. I am not playing any games this week until I have my real life stuff in order. Maybe we're gonna do GTA racing on Friday. That should be fun. But yeah, I'm doing rocket launches and space news. So with that being said, we'll stop space news. We'll check space news here. What do we have? So we have message in a booster. That's alpha at 9:30 on Wednesday. So I'll be here in the morning for that. We have Electron at 11 right after that. So Wednesday we're going to be doing a lot of streaming. Then we got, oh, geez. You know, that's going to be a lot of streaming, man. Jeez. So you're punishing us for your life failings. You guys were the one that originally gave me a lot of cash to go down to see Starship and go to these Starbase trips. It's kind of your fault. If you didn't do that, I wouldn't have this problem. Reminder, not a colonoscopy. That's right. So, yeah, guys, I'm not going to be doing much gaming this week, just because I just got to get everything around me fixed. There is clutter all over the place. Like, I am ashamed, but look, I have water bottles all over the floor. This place is completely wrecked. all of my aggregate time that I usually would have, like cleaning this place and keeping the shop nice and neat, was taken up because I went down to Texas. I was 2 weeks down in Texas for Flight 8, and a week before that, or a week for Flight 7, really screwed all my aggregate time. Turns out when you own a house, the stuff never stops. So I need to get my head out of my tail. Figuratively, not actually. Hire a maid to clean the shop. I do not like having someone pick up after me, Tessa. I will do it. I don't know why I'm not looking. You're trying to give me a solution to a problem I'll fix myself. I don't need another solution. I need more aggregate storage. Yep. So, yeah, guys, I will see you guys tomorrow for Space News. Yeah, for Space News in the afternoon. Don't get me wrong, guys. I'm not just cleaning this because it's a pigsty. I'm cleaning it with the intention. Okay, so the shop. I'm cleaning the shop with the intention of working on stuff in there with you guys. That's the whole point. Oh, don't forget the bit where you fix all the house stuff and then the cargo's kaput. Yep. Secret projects? No, I have a 69 Coronet. A 69 Dodge Coronet that I want to fix on stream. It's rusty. I want to get the welder out, and I want to do welding streams with you guys. So, I need shop space to do that. My shop is full of boxes right now. Still waiting for Toothpick EJ to make a return. Oh, gosh. Yeah. Okay, so. Did mean... Urban, you got to buy your first Ford, though. Oh. Don't forget that bit where you fix the house at the cargo. Oh, no, that's good, Urban. Yeah. Fords are nice. I'm quite fond of those. Not my boxes. We threw those out. The garage. Oh, there it is. Yeah, what are those boxes to the left of the truck, Ernok? Nope. That's this cross-member box. It's still there. That's how long it's been since I cleaned the garage out. Yeah. Ernok and I worked on the car in June of last year. The garage has been a mess since. I need to fix it because I want to build cars and I want to do shop streams where we do cool stuff in the shop. You need space in the shop to do this. The shop space is just taken up with trash. I want to fix this problem. Is that fair? Cool. All right. Bonfire. Anyway, guys, I will see you guys tomorrow for Space News. And yeah, once again, I'm just going light on the gaming this week. I appreciate the patience. This is, once again, I want to give you guys all the gaming content that you need. This stuff wears on you. I don't like streaming in a pigsty. It's gross, and it affects the streams. I don't stream as well when I don't have my stuff handled. You know what I mean? I have to do that damn adulting thing. Ugh. Freaking annoying. But anyway, I'll see you guys tomorrow for Space News. And once again, any rocket launches at any time, we will be covering this week. So if I'm not going to be gaming, that gives me the time to do the rocket launches. So all the rocket launches are getting covered. And I'm also doing Flame Trench on Friday and GTA Racing on Friday. So that should be fun. So once again, thank you very much for watching. I'll see you guys all tomorrow for Space News. And I hope everybody has a good night. Thank you.